This conference will now be recorded.
We've got Joshua Lange, right?
Yep.
Last name is Lange. He's someone that Dana referred us to, and we appreciate him being here. He's an engineer by profession. He's actually a forensic engineer, does forensic work, and it's fascinating, some of the things I've discussed with him. And I'm just going to get switched over here so that he can use his. Okay. You should.
Looks like it works.
Cool.
I guess I'm on.
Yes. Would you just kind of give a background, just a background of what your background is, why you got into this in forensic investigations and so forth?
Sure.
I would appreciate it.
Well, first of all, thank you all for giving me some time this evening. Appreciate you letting me speak. Again, my name's Joshua Lange. I typically go by Josh. I'm a mechanical engineer. Presently, most of my time I spend doing forensic engineering, which I'll get into a little bit more in detail what that entails and what that's about. I've been doing that for about 7 years. Prior to that, I designed HVAC and plumbing systems for about 8 years. And a little bit before that, I designed archery equipment, which is obviously not related to plumbing, but it does come into play in my forensic work. So as a forensic engineer, most of my work is related to HVAC, plumbing, and fire suppression systems and related failures or construction defects. As a side note, again, not really related, but I also do investigations into shooting sports injuries. So most of the time it's self-inflicted archery or firearms accidents where people blame the equipment on the accident rather than user error. But anyway, that aside, as far as how I got into forensic engineering, I guess I did design for quite a while and wanted to try something different. I started out doing forensic engineering back in Charlotte, North Carolina area. So I traveled all around the Southeast looking at various failures. That was interesting as well as entertaining if you consider that there's sometimes a little bit of a redneck twist to some of the things that go wrong. But I've been back here in Utah for almost 4 years. And so I guess we'll move on and I'll tell you a little bit more about what I do. If the technical difficulty here.
Yeah, but I had to keep switching around. It's befuddled itself. Maybe everyone has to do it for you.
Well, that's fine too.
There we go. Just let me know when you're ready.
Do you mind if I have the laser pointer?
Oh.
Just in case I. Okay, so quick outline of what the presentation is going to entail. First, I'm going to go into forensic plumbing engineer. I'm focusing everything on plumbing, but a lot of it would still be pertinent to HVAC or fire suppression, if any of you are into that type of work. I'm going to talk a little bit about how a forensic engineering project gets underway, kind of who hires me, what happened, how that comes to pass. I'm going to get into briefly kind of the things that I do as part of a forensic investigation. And then I'm going to talk about some common problems. I'll state that oftentimes I get some wild things that happen that are kind of outliers, but I would say better than half of the problems that I see or the losses that I deal with are pretty repetitive, same sorts of things that happen over and over. And you'll hear me probably throughout this presentation refer to a loss. In terms of plumbing losses, really it's the flood that occurs after something breaks. Obviously the cost of replacing a valve or something is very small compared to flooding a building, for instance. So after that, I'm going to get into some case studies, do some residential and a commercial case study, and then I'm going to talk a little bit about a few defensive measures, maybe some things you might want to keep in mind during your projects that might help to avoid some of the common things that I run across. So if you could switch to the next slide. So first of all, what is a forensic engineer, or what is forensic engineering? I find lately, every time someone says forensic, because of shows like CSI, everyone thinks it's so cool and sexy, but maybe not quite so cool if it's plumbing and HVAC, but nevertheless, I still find it interesting. But I found this definition in a book, states the investigation of failures ranging from serviceability to catastrophic, which may lead to legal activity, including both civil and criminal. I have yet to come across a criminal case involving construction. Most of it tends to be civil, or all of it, in my experience, has been civil. But anyway, there's a little idea of what that is. If you could switch to the next slide, please. So first of all, how does a forensic engineering project start? Obviously, there are plumbing-related losses. Again, talking about floods. These are cases where you have a pipe or a component that fails and releases water into a building, causing lots of damage. I see up there in the right corner, that was a project that I dealt with at the University of Virginia. They had I believe it was a 24-inch chilled water main that ran from the central utility plant through the campus that burst and flooded out a medical facility. So that's an example of a plumbing or piping related loss. The next thing is going to be construction defects. Construction defects sometimes result in a loss, but not necessarily. I find that there are, maybe not so much in Utah, but other states where I have done work, there are groups that really nitpick through buildings, and while maybe it's a facade issue or a roofing issue, they'll try to bring in as many contractors as possible, and they'll hire engineers to evaluate the installation with respect to the code of a plumbing or HVAC system, and litigation procedure ensues after that sort of thing. So that's another avenue. And then the last is breach of contract. These are types of issues where typically you have contractors that have a contract with each other. One of them installed something and the other doesn't feel that they got what was in the contract, and so there's an evaluation of what was installed and whether or not the installation was per the contract. Switch to the next slide, please. So who engages the forensic engineer? Or in other words, where do I get the work from? First, it's insurance companies. Insurance companies will hire me to perform an evaluation after there's a loss. And there are two reasons that they're going to want to do this. First, it's to evaluate coverage, and second, subrogation. Now, I don't really get into coverage issues or necessarily the subrogation. I just perform the evaluation and would issue a report, either verbal or written. And on their end, they typically have attorneys who evaluate the policy with respect to the information that I provide about the loss. For those of you who don't maybe know what the word subrogation is, I'll give a little explanation, because I realize that's not maybe colloquial as a term, but Subrogation is basically, let's say for instance, you own a home, you have homeowners insurance, you pay your premium every month, and one day you come home from vacation and you realize your house is flooded, so you're going to call your insurance agent and make a claim. They're going to send somebody out to, an adjuster out to evaluate the claim, and eventually they're going to cut you a check, or they're going to get people to fix your house. Well, then on the backside, the insurance company is going to want to try to recoup that money that they just shelled out to redress the issue that came to pass. And so they'll send in a forensic engineer to evaluate, for instance, the plumbing system, to make sure that there aren't any installation issues or product failures that are the cause of the flood that happened. And if they find that there is an installation issue, or if there is a component failure, they may decide to try to subrogate or go after the person or entity that they deem responsible, so they can get their money back effectively. So the next avenue for engaging a forensic engineer typically comes from attorneys. They're going to want an expert witness. So I do some of that. I've done some of that where I'm either being deposed or I'm up on the stand during court, and I'm basically giving my expert opinion about what I think went wrong based on my evaluation. Other times, the attorneys will be involved with a forensic engineer because they're helping an insurance company subrogate, for instance. And a lot of times, because the forensic engineer was brought in by the insurance company at the forefront, once it goes to litigation, the forensic engineer sort of follows the file with the lawsuit to the attorney and the impending litigation. So, and then the last way is through contractors, which is not real common, but I do get hired sometimes by contractors, and typically it's a matter where the insurance deductible is very high, $100,000 plus on a big project, and the contractor has a certain familiarity with a forensic engineer, and they want to get things rolling with that individual rather than turning that responsibility of choosing the forensic engineer over to the insurance company. So again, it's definitely the minority of cases, but sometimes it does come through the contractors. You could switch to the next slide, please. So just a real quick overview of what an inspection or evaluation by forensic engineer would look like. And of course, there are going to be intricacies with each situation, but these are sort of the basics that one would see normally in any sort of investigation. First, I'm going to interview the involved parties, any contractors, subcontractors, building owners, those sort of people who might have some insight, who may have seen something that can help point me in a direction. Of course, I do take the interviews maybe with a little grain of salt, because sometimes people are motivated to tell stories. But oftentimes it's pretty obvious when the story isn't consistent with my evaluation. And also, I find if I were to interview a half dozen people, the person who's making things up tends to be the outlier. So it gets pretty easy to tell, again, given the other people's account of things as well as my evaluation, it's typically pretty easy to tell when somebody's making things up. So then I'm going to walk the site and take a lot of photos to document the conditions post-scene. Then I'm going to dive into the construction plans and specifications if they're available and if it's pertinent. I'll evaluate the engineering design. Sometimes an engineers actually do make mistakes. Maybe a lot of times. Sometimes. Then I'm going to go through, in a construction project, I'm going to go through emails and other project correspondence, RFIs, things like that, that sometimes give insight into what transpired. And finally, I'm going to review applicable codes and manufacturer installation guides and other industry sources, which might give some insight again into best practices, things like that. So when it comes to common related or plumbing related problems, as I think I stated earlier, there are a lot of things that are really out there that I see, but I would say the majority are repetitive type issues. And the issues are a little different whether they're residential or commercial. So over on the left, you see the residential side of things. I see a lot of missing pressure reducing valves, or the pressure reducing valves no longer working. I see a lot of expansion tanks that were not installed, or sometimes the bladder within the expansion tank will get punctured, so it's basically completely filled with water. And the last thing I see often is over tightening of plastic parts leading to creep failure. Creep failure, if you haven't heard that term, I won't get too deep into it, but basically thermoplastics are viscoelastic, which means there's an elastic component in their behavior, which is kind of like steel. You bend a steel spring and it springs back. As long as you don't deform it too much, it's going to work in that elastic range and have those elastic characteristics. The viscous side of viscoelastic has to do with viscosity, which is kind of like the difference between pouring out a glass of water or pouring out a glass of honey on a cold day. The honey is going to be very viscous. Thermoplastics, even though they're apparently solid, are actually still somewhat viscous. And so if you apply a stress over time or pressure over time, it's going to slowly deform. And as that happens, the stresses can continually increase and lead to failure. And so you see that sort of thing in plastic connections, like on a toilet connection, for instance. And I'll get into a little bit of that more later. But switching over to the commercial side of things, most of the time I see things like deviations from the plans or specifications, unapproved substitutions of equipment, other trades utilizing or altering the plumbing system during construction. That actually happens a lot more than you would think, or maybe you would think it happens a lot more than I think, I don't know, but it happens a lot. And the last one is pipe freezes. And the pipe freezes, I find, are either related to insulation not being installed properly, which of course, in most cases, the plumbing contractor has no idea that the installation was not installed correctly, or the building wasn't adequately protected from freezing during the construction process. Next slide, please. So now I'm going to move on to some case studies. I'm going to do 2 residential case studies and 1 commercial. So the first one is an apartment plumbing loss. This one I'm saying is residential because it was really a house that was converted into a 6 apartment unit, or 6 apartment units. So a little bit of background on this. The apartment units were newly renovated. In fact, there was only 1 tenant who had just barely moved in. The rest of the building was still vacant. And that particular tenant had been at work all day, and when he got home, he discovered that water had filled his apartment. And he had called the landlord. The landlord got somebody over there, and they reported that they found that the plumbing riser that goes up to the vanity in one of the 2nd floor bathrooms had basically popped out of the stop valve connection. Somebody want to reach over and move the slide? Is that where I can get up and I got it. Okay. Thanks. So I should probably state that typically when there's this sort of a loss, whether it's residential or commercial, they don't call me within minutes of it happening. So I usually get there a day or two later. So in this case, I think it was a couple days later. So the first thing I'm going to look at is what's the pressure of the plumbing system. So real quick, I just put a pressure gauge on there. And initially when I got there, it measured at 93 PSI, which obviously is pertinent because 80 is kind of the magic number. The city pressure is going to fluctuate. And that's why you see I got my phone there in the picture with the time, because throughout the inspection, which a typical inspection is going to be, I would say 3 hours, I will check it multiple times throughout that 3 hour period just to see how it's fluctuating. And the other reason it might fluctuate, of course, is if there are water heaters and no expansion tanks, I'm going to see some spikes in pressure as the water heaters cycle. So again, the code requires 80 PSI. So anything over 80 PSI, as you see there in the International Residential Code citing that I have there, you're supposed to put in a pressure reducing valve. You can switch to the next slide, please. The next thing I'm going to look at is the meter vault, and I'm going to check for a backflow prevention device or check valve. And in this case, of course, there is a check valve, which now, according as well to the International Residential Code, there should be an expansion tank insofar as there are tank-style water heaters. So now that I've sort of covered those two bases, I'm going to start looking at things inside the building. I should probably add, when I do the pressure tests, I'm typically just doing that from a hose bib outside. That's the most accessible. You can switch to the next slide, please. So now I'm entering the building and again looking for a pressure reducing valve. And in this case, there was no pressure reducing valve. There wasn't one right as the piping entered the building, and there weren't any of the branch piping to any of the units after that. So obviously we have an issue there. And I should add that there were actually a number of issues on this particular installation. Probably see that the PEX piping is connected directly to the water heater, for instance. And as a side note, I learned later that it was the building owner's handyman friend who came over and installed the system, not a licensed plumber. So there were a number of code violations that I found in addition to the items that I'm going to talk about here. But you may see some of these other issues in the pictures as we're going through. If you can switch to the next slide, please. So the next thing, I'm looking for expansion tanks. Each unit had its own water heater, and I didn't find a single expansion tank in any of those areas or anywhere else in the building. So again, we should have expansion tanks according to the code. Next slide, please. And so in conclusion, again, the water supply pressure exceeded 80 PSI, but there was no pressure reducing valve. The presence of the check valve in the meter vault required expansion tanks at the water heaters, but there weren't any present. And so my ultimate conclusion was that cyclical rises in pressure exceeding the code prescribed normal operating pressure of 80 PSI regularly occurred as the water heaters cycled and due to city line pressure fluctuations. And the pressure fluctuations caused the connection between the riser tube and the stop valve to loosen and ultimately separate. So you probably noticed the wonderful drain piping in that vanity too, which is really nice. Anyway, next slide, please. So this is another residential style plumbing loss. This home was built in the mid-90s, but they reported that the toilet had been replaced a few years earlier. And this was one of those cases where the homeowner returned from vacation and found water damage throughout much of the home. I think 9 times out of 10, it's always in a residential setting. Somebody's come home from vacation and they find a mess, which I suppose makes sense if you hear the water running, you run and shut it off, and you're not there for a few days, you're going to have a big problem. So, that's why there's no valve for that. So, in this case, they reported that the plastic nut on the toilet connection had failed. And so we'll look at that in just a minute. If you switch to the next slide. So in this case, I went through some of the same steps, and I'm not going to reiterate because kind of got the idea, I think. But the pressure test showed that the system was operating in an acceptable range. As I recall, it was around 60 psi. The system did have a pressure reducing valve, and the system did have an expansion tank. The expansion tank seemed to be operational. At least there was air in the tank, and the pressure in the tank was pretty close to what I would expect, being about equal to the pressure in the line. Next slide, please. So then I looked at the failed connection, and the mode of failure appeared to be consistent with creep, which I talked about a little bit earlier. This type of failure on the toilet connections is, I would classify as very, very common. I see a lot of this. And I also see a lot of tool marks on the nuts, which is an indication that they may have been over tightened. Most of the manufacturers specify that you're supposed to hand tighten them only. You've probably seen some of those nuts actually have the instruction hand tighten only on the injection molded part on the bottom of the part. Others have it on the tag that is typically on the part as well. So something to watch out for. Next slide, please. So the conclusion in this instance, it seemed that the plumbing system appeared to be functioning within a normal pressure range. Creep was, again, reasonably the mode of failure of the plastic toilet supply nut. However, the final conclusion is while the markings on the toilet were consistent with having been replaced within the last 3 years, the toilet connection appeared to predate the toilet. In other words, they reused the connection, and it could not be determined whether the tool marks in the plastic toilet connection nut were from the original installation or the more recent toilet replacement. So in this case, when I delivered that conclusion, the insurance company decided to basically drop it, that they weren't going to try to subrogate against anybody because there's really nowhere to go. And so I point out the two instances kind of so that you can compare the two. In the first one, I did the evaluation. There were some problems. There was a clear, and again, I'm not an attorney, but it seems to me it was pretty clear that there was an avenue for subrogation because whoever installed the system didn't do it to code. They omitted some things. In this instance, we have something that's a little bit more inconclusive, and they didn't pursue subrogation. So I guess I'm pointing these out to illustrate that sometimes the forensic engineer can be problematic for the installer, and sometimes the forensic engineer can be a blessing to the installer. I try to sort of be very objective and look at things that way. I don't really have any interest per se in whether or not an insurance company subrogates. And so, again, it can go both ways. So then this is the last case study that we'll go through. This one was obviously commercial. It was a 50 megawatt turbine generator that provided power for the Food and Drug Administration campus in Washington, D.C. I believe it was one of 9 turbines in this central utility plant. They had a central utility plant. They were adding on a second central utility plant. It was I think a couple $1 million shy of $1 billion project, and this turbine was part of that project. So when the failure happened, it hadn't been completely turned over. The project hadn't been completely turned over to the owner. They were still in the process of doing some startup and commissioning of the many different components in that system. And during that period, which I believe was over a year of the startup and commissioning of the various components, this particular turbine's inlet air cooling coils froze and cracked. And then later in the spring, when the inlet air cooling coils were brought back online, they did so while the turbine was running, and it dumped many thousands of gallons of water into the turbine while it was operating. So next slide, please. So just a little bit of what I saw when I got there. You've got the 2 inlet air cooling coils, and these things were pretty big. I believe they were about 42 inches tall each and about 8 feet long. So pretty big equipment. But over on the right, you can see the coil bends. Every one of those black marks are where one of those bends had burst. And before I arrived on the scene, they tried to do some repair. I think it was maybe an effort in futility, but each of these coils had pretty much every one of those bends burst all the way up to about midway up the coils. And so the attempts to repair all the leaks were unsuccessful. Additionally, there are actually some leaks within the 8-roll coils that they really couldn't access. So the coils were obviously junk at this point. Next slide, please. So getting back a little bit to what I talked about earlier is the steps that I go through in performing an investigation. The first thing I wanted to look at was whether or not these coils were actually winterized. They chose at some point not to use glycol in the system. They decided to go with straight water, and they decided that they were going to winterize the coils every year. And they didn't do it by date either. They just sort of did it by, as soon as we think the weather's going to get cold, let's hurry up and drain them the week before or a few days before.
Let's not have a snap of any kind. Yeah, all right.
So I started out interviewing key personnel just to get an idea of whether or not they actually were winterized and when. Then I looked at emails, and there were all sorts of email chains about cold front that was coming in, and we better get these things winterized soon, this sort of thing. There was also handwritten logs. There was an entity or a company that was in charge of running this plant, and so they kept a daily or actually an hourly log, which you see kind of some of the handwritten excerpts there. And then I looked at the historical controls data. So obviously an operation like this, they're going to have a building management system, and thankfully they had lots of control points between sensors and valves, and they were recording the data from all of those points, and I think it was set up to hold that data for a year. So there was
They're taking all that data but not using the data. Huh?
Yeah, I don't know that they had gotten to the point of using the data yet. So And then I looked at the historical weather data. So obviously I wanted to look at when freezing temperatures occurred. And that's very easily accessible through NOAA, whatever that is, National Oceanographic something or another. They do more than just tell you where Santa is on Christmas Eve. So I was able to get the historical weather data and compare it to the logs and compare it to the controls data, etc. And did determine that the mechanical and plumbing contractor did perform the winterization, and it seemed that he did it correctly, and that the coils were in fact drained before the freeze event. Next slide, please. So knowing that, obviously it seems that they had to be refilled at some point. And so now I started looking into how that might have happened. And so as it turns out, they were refilled, it seems, in January by the, for commissioning. So I learned this. First, it was hinted in some of the interviews that I had with some of the personnel. Then I was able to look at some of the controls data and, of course, the weather data. Interestingly, there is a condensate drain tank that has a float in it to measure what the level is. And so I was able to find the control point and the data from that control point for the float. And it coincided with filling or changing the level a little bit so there was a freeze in January, and then afterwards there was a thaw. And a day or so after the freeze is when we suddenly see water appearing in that tank. So it seems to me that that's when the freeze occurred. And when we were able to roll that back again with the interviews and the controls data, it seemed that the valves were opened for commissioning. And there's also a record of the commissioning agent being on the scene in the logbooks, that it looked like just prior to that freeze event, they had filled the coils, they shut the manual valves to the coils, but they never drained the coils after they had performed their commissioning. So seems like that's how the freeze happened. And I would add further that because we knew the size of the tank, the condensate tank, and the controls point told us what percentage it was full, we were able to sort of compare how much water would have been in the coils versus how much water ended up in the condensate tank, and it was fairly consistent. So next slide, please. So again, the inlet air cooling coils were brought online when the turbine was running. You see a couple of the pictures there. I got to the scene, I think, 2 days later, and they were still trying to soak up the water that was dripping out of the turbine. So again, interviewing key personnel, looking at the emails, the handwritten logs, the historical controls data, and the weather data, gave a lot of insights into when they were filled, and it coincided with the weather and things like that, of course. So in this case, the facility's operators opened the manual valves to refill the inlet air coils at their discretion. The inlet air coils had not been commissioned yet, hadn't been turned over to the owner yet. They were still under responsible care of the mechanical plumbing contractor. And again, these individuals, they acted without ever notifying the mechanical plumbing contractor who had responsible care of the equipment. But it didn't, I guess, stop the lawyers from looking at the plumbing and mechanical contractor, even though they aren't the ones who initiated the flow of water. Anyway, so the water gets turned on. Again, it fills the turbine that's running with thousands of gallons of water, and immediately the turbine goes into alarm. The operators see this, they hit the emergency stop, and the turbine never ran again. Next slide, please. So then on to the disassembly of the turbine, because I wanted to see whether it was salvageable, could be repaired, what actually went wrong. And as it turns out, the thermal shock of ingesting the water, it seemed, while the turbine was running, cracked the cooling shroud. So over here on the right, this is the combustion chamber for the turbine, and this outer portion is a cooling shroud. Air passes, some of the air, instead of going into the combustion chamber, bypasses the combustion chamber and goes to the outside and provides cooling so that you don't melt the chamber. This is a close-up of sort of the top edge, and you can see this big crack. So this piece of equipment is going to be operating at, I don't know the exact temperature, but it's going to be well over 1,000 degrees. And now you dump cold water in there and a crack, right? But as part of this crack, you see there's like a chunk missing right here. And what we think happened is that the chunk, or many chunks, went downstream and ran into the blades. And you can see some of these dents and things that are marked here. In some of the other blades, in the other stage of the turbine, there were actually some chips. But a turbine like this operates, I believe, at 14,000 RPM. And so any little deformation or crack or anything can cause catastrophic failure. So at this point, the turbine is done. It has to be completely refurbished or replaced. And so that's what was determined. The entire turbine generator assembly had to be replaced at a cost of nearly $8 million.
Who paid for that?
Lots of people.
Mechanical contractor.
Yeah.
They weren't left out of it. So next slide, please. So here's the big lengthy conclusion. Sorry for how wordy this has gotten, but so the mechanical plumbing contractor had not turned the IAC coils system over to the owner and was therefore still in responsible charge of the equipment. The equipment was operating at the direction of the general contractor and the facilities management group without notifying the mechanical and plumbing contractor. The general contractor had a lockout tagout policy that included protecting equipment from damage in addition to the OSHA requirement of safeguarding human life. And all of the subcontractors were required to complete the general contractor's lockout tagout training and follow the policy. And as it turns out, the mechanical and plumbing contractor did not follow the lockout tagout policy after winterizing the coils. And additionally, the general contractor wasn't enforcing his own lockout tagout policy on site. And so when you ask the question of who paid the $8 million, I think it was kind of spread around. Ultimately, there were some settlements and they were undisclosed amounts. So I don't know who caught most of the blame or less or more of the blame, but that's kind of how it went down. So, and you know, maybe as a little bit of a cautionary tale, it is great to have policies, and whether it's safety policies or whatnot, insofar as you follow them. Because if you don't follow them, then some forensic engineer is going to dig up something, and it's probably not going to bode well for you if it ever goes to litigation. So, again, policies are great as long as you're following your own policies. So let's talk a little bit about a few defensive measures. I'll start with the residential side of things. And just to reiterate, talked a little bit about some of the common things: missing PRVs, missing expansion tanks, and over-tightening plastic parts. One thing I've seen some contractors do is they photograph some of the key components when they're done with the installation, which I know sounds a little odd, but you'd be surprised at how many times somebody moves into a new house and they try to fill their Whirlpool tub, and well, my 40-gallon water heater doesn't quite do it, and they're thinking they they need a bigger one or they need a second one, and who do they call but their handyman friend down the street who says, I don't know why we need this expansion tank, we'll just add the other water heater. And when something goes wrong, all of a sudden they're looking back at the plumbing contractor, even though he might not have been the one who altered the system to bring it outside of code compliance. And so as a recommendation, probably take you 15 minutes, might be a good idea to take a quick photo of the PRV and the expansion tank and some of those things and just throw it in the file. As I understand it, the statute of limitations is 6 years in Utah. I'm not an attorney, but that's what I've been told. So it might not be a bad idea to, keep a few of those photos in your file for that period of time. And then the other thing is be familiar with the manufacturer installation instructions of some of the parts that you're using repetitively. As I kind of mentioned earlier, here's an example in that photo of the part that actually says hand tighten only. So it's good to know that it says that instead of applying a channel locks and maybe causing a headache for you down the road. So next slide, please. So then on the commercial side, just to reiterate again, the common things I see are deviations from the plans or specs, unapproved substitutions, other trades utilizing or altering the plumbing system during construction, which obviously we saw with the turbine case, and then the pipe freezes. So some of the defensive actions I would recommend would be to seek engineering approval when deviating from the plans and to get written documentation of those changes, whether that's an email or response to an RFI or something. I understand the urgency sometimes of trying to get things done and the engineers aren't responding quickly enough, but if you deviate from the plans, it's sort of, if something goes wrong and it goes to litigation, it sort of absolves the engineer of responsibility, and the plumbing contractor ends up taking on more of that liability or responsibility. And it's best to get that written confirmation that it's okay to deviate in the way that you're suggesting. Similarly, seek engineering approval before making unspecified equipment substitutions, because again, if something breaks, something changes, it gives an easy avenue for an attorney to point at something and say, well, you didn't follow the plan, you didn't follow the specification, and you don't want to take that liability on yourself if you can help it. And then the last one is lock out or tag out the systems that you are responsible for to prevent tampering insofar as you're able. I think if obviously the plumbing mechanical contractor in the turbine case could have, I'm sure he would have put some locks on those manual valves after he winterized the system. And you may have noticed that actually when I showed up on the scene, in one of the photos that was there were actually lockout, tag out devices in place now that the accident happened. So I guess they learned quickly.
Very quickly.
All right, so that's the conclusion of the presentation. Anybody have any questions?
Does anybody online have any questions? Just unmute your microphone and.
So how often do you get called in for the same thing over and over, do you think? Is it pretty common to get called in for the valves and the toilets and the
Yes,
supply tubes? That seems like
that's
very
super common. I mean, it seems to come in spurts, but I mean, when I'm looking at residential property losses.
Are you finding that with the braided hoses as well?
So the braided hoses, I find a lot of times they pop out of the crimp connection. Yeah.
Interesting. I haven't seen that one.
And when I see that, it's typically
over tightening though.
No, it's not from over tightening. It's from lack of pressure reducing valve and lack of expansion tanks.
Excess pressure.
Yeah.
Do you use a lot of tattletale gauges or any of that? We had one that the city actually bumped the pressure at night that we found the pressure reduced, I mean, above almost 200 PSI in Provo.
Wow. Yeah, I haven't,
And blew the pressure reducing valve right off, blew right through it. We had to put a tattletale gauge on it to find it. We couldn't figure it out.
okay. I haven't done that.
What do you mean by tattletale?
You know, the gauges, the lazy hand, so you put it down and then it'll take it to the highest point and it just, it stays there. It won't come back. So you put it, that's the only way we were able to find it. We couldn't figure out how was this thing over pressurizing.
Sure. So I have put on like a pressure data logger, which is the same
data
thing,
logger.
but it's,
Okay.
but I can, plug it into the computer and it says what the pressure was over time.
Does
but-
it, how does it keep track of it? That's what I was wondering.
So you just connect it to like the hose bib, and then
Right.
it samples every, I forget what it is, but it's like every several times a minute, and then it
Interesting.
downloads millions of data points, and then you can basically
That one I've never heard of.
you can dump that data into like a spreadsheet, and you
Oh.
can see over time.
Okay. And it's called a what?
It's a pressure data logger.
And you can get them where?
You can find them online. Probably they're about $500.
Oh, yeah.
So I've used them, but I haven't found when I've applied them, if there was a pressure spike, it was before I applied it. So then it didn't show any pressure spike subsequent to the application, unfortunately. But
Pressure data logger. I didn't even know they made such a thing.
so I guess that's the more high-tech version of what you're talking about.
Okay.
But yeah, certainly on a residential level, the problems that I see are very much the same over and over and over.
Mhm.
And I guess a lot of that has to do with the fact that there aren't that many components that are different from one system to the next. Whereas in a commercial system, particularly when you get into HVAC mechanical systems or even process piping for plants and stuff like that, everything's different and it's unique. And so the problems are less repetitive. They're more problems fundamentally rather than physically the same, if that makes sense.
That's cool. I didn't know they made those. Cool.
Any other questions from anybody? Josh, thank you very much. We appreciate it very much. I think it was very apropos, very informative. Those who are online, would you just make sure that you email me your license numbers? There's a few there that I don't recognize names or the names aren't listed. So I'd appreciate it. Thanks a lot, everybody. Remember, December, we won't have a meeting. And please write from that email that we sent out today that you send to the task force committee. We'd appreciate it. Thanks a lot, everybody. Have a good Thanksgiving.